Okay, thanks very much. Our presentation's in three parts. We're going to talk about designing and delivering the Wolverhampton Passive House schools at no extra cost. Archetype, Elemental Solutions and Thomas Vale Construction, myself, Jonathan Hines, Director of Archetype, Nick Grant, our Passive House consultant, and Matt Wisdom representing the contractor. We're each going to cover one part. I'm going to talk about the challenge of design. Nick's going to talk about achieving the standard, and then Matt is going to talk about the reality of building it. The team, first of all, we're the architects, Archetype, Nick Grant and Alan Clark, Passive House Consultants, E3 Consulting, M&E Consultants, and we've got them represented in the room. Structure Engineers, Price & Meyer, QS Smith Thomas Consult, Landscape Design, Co-Design, Certification Warm Low Energy Design. Our client is Wolverhampton City Council and the contractor, Thomas Vale. So my first part is called the challenge of design. At Archetype, we're passionate about design and design quality. And what we want to show you is how we're realising our belief in quality design at the same time as achieving Passive House. And there's, again, two elements to that in terms of these projects, is designing delivering on the design and delivering on the educational agenda. In terms of design, Archetype describes its approach to design in five key philosophies. First of all, we want our approach to design to be engagingly collaborative, to collaborate with our clients, the children, the teachers, our design consultants and the contracting team to achieve a collaborative approach to the design. We then want to create designs which are elegantly simple, that are radically ecological, that are uplifting and enriching, that it's architecture that is good for the soul as well as good for the bank balance and the carbon balance. And buildings that are robust and timeless, that can have a long, useful life, that don't go out of fashion, that are easy to maintain and look after over many, many years. And then in terms of education, we're looking at buildings that take that philosophy and then deliver on a radical sort of educational agenda. And the example which illustrates this best, which predates our Passive House schools, is St Luke's Primary School in Wolverhampton, which really sets the design and educational standard for the projects, which also incidentally was the first primary school in the UK to get BREEAM Excellent. We worked here in a very tough inner city part of Wolverhampton to deliver a sort of radical approach to highly insulated, triple glazed, timber clad building full of natural daylight, of natural materials, so that the energy consumption is good, but also the quality of the spaces are good, the environment is good. Everything that the children feel and touch, the handrails, the floor finishes, are all natural materials, timber, lino, rubber, natural paints, in order to create a calm, enriching, uplifting atmosphere in which children can learn better and children can teach better, teachers can teach better. And if you want to see a little video about this school, it's down on the Vale Archetype stand downstairs, where you can see the children talking about how much they appreciate the school. Full of natural daylight and beautiful spaces, we believe that school buildings should be great places, great pieces of architecture, not just machines for learning in, places where people can actually breathe and live and be. So the two Passive House projects, also for our client of Wolverhampton City Council, Oak Meadow Primary School, a 2-form entry plus nursery for 450 children, and Bushwick Hills Primary, a 1-form entry plus a nursery and a special support unit for 240 children. The timescale, we were appointed in December 2009, had to get to planning and tender by April 2010, contractor appointed by June 2010, on site September 2010, and completed by October 2011. So quite a demanding programme. I'm delighted to say we handed over the first school last week and the next school this week, and the children will be starting in them next week. So why did we do these schools to Passive House? Primarily because Archetype promoted the idea to the client as a more sensible approach than BREEAM, as a more robust way to reduce carbon emissions, i.e. use less energy rather than offset it, and to achieve lower running costs for the schools, as well as creating better internal climate environment for the occupants. But also because we responded to the client's challenge, that all sounds great, but you must achieve it at no extra cost without any impact on the very tight programme. So we had a standard allocation for a primary school in the then primary capital programme, and if we wanted to do Passive House, we had to deliver it at no extra cost. Now everybody says Passive House costs 5 to 10% more, or this morning 15% more. What I ask is, how much does construction really cost? So I'll just introduce you to the John O rule of cost estimating. which is if you think it costs more, it will. And the price is a matter of priority. And I find so often, particularly when I'm doing design reviews in Wales with the Design Commission for Wales, that architects come and present a project and they say, we can't afford to make it any more sustainable. I look at it and they've got complicated plans, sections, they've got bits of structure flying through everywhere, they've got 5 or 6 different cladding materials on the elevations, they've got tricky junctions everywhere, and they say they can't afford to make it more sustainable. And I say to them, no, you've chosen to take your client's budget and spend it on architectural complexity. You could have spent that money and make it more sustainable. Now, obviously, there are extra costs. There's more insulation, there's better performance windows, there's achieving better air tightness, there's providing MVHR. There are also reduced costs in school projects. We have a smaller heating system. We can get rid of the need for underfloor heating. In fact, it's better without underfloor heating. We can have much simpler controls, and we have no requirement for renewables to reach our targets. And there are some things which obviously shouldn't cost any more. If we design a good building, it shouldn't cost any more to build. If we eliminate thermal bridging in the design, that won't affect the cost. We keep the construction simple. It should actually make it cheaper, maybe. So our hope at the outset was that we could achieve Passive House at no extra construction cost. And Matt will talk more later about how or whether or not we achieved that. But our belief was that to achieve that, we had to focus on simplicity and evidence. By simplicity, I mean looking for what we can take out to make a building work better. The simplest way to achieve simplicity is through thoughtful reduction. What can we take out of a design just to make it work better through its fundamental architecture? The great jazz musician Charlie Mingus, making the simple complicated is commonplace. Making the complicated simple, that's creativity. Some of the most elegant solutions, designs in the world are the most simple, the most long-lasting. The other thing we believe is fundamental to our approach to design is basing it on evidence. Now, we like Passive House because it is an evidence-based, physics-based design approach. But one of the things I think that the UK building industry is terrible at is learning from its past projects. We seem to have a sort of process of PPP, perpetual pilot projects, that ever learning from previous projects. Car manufacturers would be horrified the way we treat our clients as crash dummies. When they move into their buildings, just have to cope with it. Hit and run it should be a thing of the past. So for the last 2 years, we've been working in partnership with Oxford Brookes University on a 2-year research programme to monitor the performance of our buildings, to learn the lessons from that, to find out what works and what doesn't work, and to inform and put that back into our design process now. So simplicity of design and basing it on the evidence of what works and what doesn't work is fundamental to achieving Passive House at an affordable cost. In fact, to achieve any design that's going to work at an affordable cost. So the projects, Oak Meadow Primary School, 2-form entry. It's a replacement of an existing primary school on a site where we were able to place the building very, very exactly on a north-south axis facing, with all the primary rooms facing due north or due south. And then to demolish the existing school building, which is on the site of the car park, once we'd built the building. If you look at the plan of the building, you'll see it's a 2-storey building. We looked very carefully at form, developed a 2-storey building, kept the plan as rational and simple as possible, creating groups of classrooms organised around shared hub spaces and logical connections, good orientation, simple planning around the building on the ground floor and then on the first floor. There's a view of the building at design stage in its context. And just looking at the plan in a little bit more detail, there's a hierarchy of spaces. We've got the group room shared between 2 classrooms. We have then the classroom. We then have the shared activity space off which the classrooms open, and we have the main school hall. And Nick will talk about this strategy in relation to the ventilation system in his session. The same thing at the first floor level, group room, classroom, shared hub space, and the upper part of the hall. When we look at the section, we work very hard to rationalise the section, to have a simple extruded section that runs along more or less the whole length of the building, allowing good solar aspect but good control. So we're really working with the plan and the form as an integrated piece of design to maximise its relationship with the environment and its performance in PHPP. Moving in on one particular section of the building, just showing you how some of the main spaces work. We've got the classroom on the left, the shared hub space in the middle, and the main school hall on the right. So you can see how each of those spaces has got good daylighting and a sense of connection and space between the inside and outside and between each of the spaces within. And there's another view of the shared hub space with some of the shared things like art and cooking and library spaces go into that hub space. And upstairs, where there's more group spaces that connect the downstairs and the upstairs together in that hub. And the same hub space in the early years, where the nursery and the young children have a shared activity space connecting their classrooms together. So from an architectural point of view, another aspect of making the architecture work with Passive House and the cost, we spent a lot of time looking very hard at the glazing. Glazing is very expensive, as you know, to get to Passive House levels. So we looked at simplifying the glazing, looking very hard at what open free areas we needed for ventilation in summer conditions, for night cooling, to work with our overall strategy. So a lot of effort there on keeping things simple, having some very big openings and secure night insulated louver panels. And there you can see the finished building in relation to how that's worked. And the view of the whole building emerging in its context. So you can see on there very simple rationale of opening doors, ventilated louvers, brise soleil, allowing good solar aspect but also good shading. The other project is Bushbury Hills, slightly smaller building. This site had a completely different orientation, but we located the building again to face the correct orientation north and south within the slightly strangely angled site. What that does do is creates a whole series of opportunities for some really interesting outdoor spaces within the site itself. Being a much smaller building, we've actually come up with a much simpler plan. Like all of our school buildings, we're trying to get rid of corridor spaces and use those as actual teaching spaces. So here, we've got the two halves of the building just pulled apart slightly to create a very, very over-generous shared access and activity space with the school hall and the kitchen on one end of it. And again, a lot of effort put into keeping the form of the building very simple. And again, extruded section that runs right through the building. Here you can see the two parts of the building, the classroom unit to the front, where we've used in this building for most of the windows, the roof overhangs on both buildings as the brise soleil instead of a separate brise soleil, so a slightly different approach on this project. And then moving inside the building, a very simple section. South is obviously on the left-hand side here, so you can see the classrooms on the south with good solar aspect and the overhanging roof for the brise soleil. We've got a number of classrooms on the north side that actually get very good daylighting borrowed through the hub space, which you can see with the yellow arrow there. And when we move inside, you can see the bottom left there, that shared hub space. Some of the glazing connecting that hub space into the classroom to the north side, and a picture of one of the rooms on the north side, which has such good daylight in it, you would never believe that it was on the north side of the building. Borrowed light works extremely well there. Hopefully in all these pictures you can see that sort of archetype combination of natural materials, timber static ceilings for good acoustics, natural liner and natural rubber on the floor, a lot of timber with natural organic finishes on it, natural paint on the walls, again a whole palette of healthy natural materials. So what we're trying to achieve, what I've hoped I've demonstrated there, is that we've managed to keep hold of our passion for design quality, of healthy building, of good daylighting, of good materials in a building which also achieves the very technical demandings of Passive House. For archetype, in the words of Steve Jobs, design is not just what it looks like and it feels like, that is fundamental, but it's also how it works. And so Nick now is going to take us through how he helped us make it work.
It would be nice to start with a small detached house. We started with 3 schools with our first Passive House project. It's a bit at the deep end, so we had to do a lot of desktop studies. You look at form, structure, ventilation, heating, primary energy and certification. So we're going to whiz through all this. There's a lot to cover, but bear with me. So started off visits to Germany with Passive House conference, been going to for some years. Alan, who I work with, he went to Belgium. There was a study tour there and looking at education buildings there. Really trying to partly gain confidence to see when you start looking at tiny boilers, tiny pumps and tiny pipes, to have the confidence to do the sums and believe the calculations. And you kind of, the seeing is believing, I think it's really important. One problem, a lot of the knowledge is only in German. There's lots of information on domestic buildings. There's plenty of that out there in various languages. When you get to schools, there's not so many built, and there's key bits of information which, not being a German speaker, we were sort of noticing interesting looking drawings and thinking there's something important here. So that was something that was a potential stumbling block. And in kitchens caused a lot of problem, because in German schools there's very few kitchens. The Reiberg school we'd seen did have a kitchen, but in Germany the kids are often going home early and they don't have full cooking facilities, whereas UK schools we tend to have a full catering kitchen. And other differences, the occupancy rates, we tend to put more kids in the classroom, our school day is longer, so the kids are there into the afternoon in terms of internal heat gains and so on, overheating. So there's a few differences. And also in Germany you often see, just quite casually, a windows left open for night ventilation. There's schools in inner city areas, we've got to think about security, we've got to think of alarm systems and birds and insects and so on. And health and safety, things that is done on the continent quite normally. Kids don't seem to die falling off things, but British schools, there's so much stuff we had to do. Windows can only open so far, 100 millimetres, otherwise a child will squeeze itself through. And so, these things, they seem silly, but it means it's very hard to just take what you've seen work and copy it. We've had to adapt stuff. Not to go into detail, just to give an idea, there is a range of, particularly Frankfurt, there's some very good documents. You can find this on the web, find stuff through the Passive House Trust website, also Passipedia now. A lot of it's open to the public, but there's specific technical bits which, if you're EFA members, so if you're a Passive House Trust member, you get access to this. And there's some articles on the school. This school's article came partly out of our discussions. There were some key questions we were asking PHI. Wolfgang put up some articles, and the knowledge came available, the critical items. First of all, analysis. This is actually done for, there's 3 schools actually. There's another one, Swillington, which was the first one we started on, but that is now on site. It was a bit later. But we did, one of the beauties with a PHPP is you can use it as a very simple tool. There's an incredible complexity in there, but you can, because it's a spreadsheet, you can write very simple front ends. And here we were just messing around with the idea, okay, we can do single story, 2-story, we can change the depth, we can rotate it. And without knowing what it's going to look like, we just put in an area of windows, so we set a windows about a certain sort of schoolish type window size. And then the spreadsheet says you've got, 57.5 windows, it's fine. The math still works. So we were able to do this analysis and try various things. So with 2-story, obviously we've got stairs and lifts, so we lose some treated floor area for that. But overall, for this building, you can see there's a real benefit, the compactness of a 2-story. The other school we're working on, which is what we did this analysis for, because it was that much smaller, the stairs had more of an impact and we ended up single story. So there's lots of things to balance, daylighting, access, costs, so many different things. But we can do this analysis and it's part of the process of weighing everything up. And at a very early stage, this thing pre-planning, we've got a sketch design, we've got the rough shape, and the architects are saying, oh, have we passed? Have we got Passive House? Pre-design stage, pre-planning, and the spreadsheet saying 14.9 kilowatt hours, and they're all going, yeah. And we're saying, no, whoa. No champagne yet. There's a real danger at the design stage, not only because you haven't got any slack, you need some slack, stuff you haven't thought about, the mistakes you're going to make, the things that come in later. But also, if you set a much tighter target when you really are at the conceptual stage with basic U values and so on, you've got a real chance of making the school cheaper. If you're too tight at that stage, you start having to use thicker walls, you have to start using very expensive glazing, you start having to get a more expensive MBHR, you start having to add things on because you've slipped and slipped. So if you can hit a really good, with your standard thing, you say, well, we can take some insulation away, let's not overdo it. So I think this is, if you want to get a cheaper building, you've got to let the form do the work. So this is what, Sabine, it'd be nice to talk to you over a glass of wine at some point, why architects, even if you don't learn PHPP, and it seems daunting, but it's just very basic physics. And I think it's got to be, whether it's the engineer in your office or it's you're learning it yourself, that interaction, that iteration is really important. That happened with these projects. PHPP aside, the other thing I feel passionate about is sort of thinking how all the structure happens. And I look at nature with the human skeleton or any mammal. Generally in nature, the skeleton's on the inside or the outside, okay? And for mammals, it's on the inside. So this is coming up in the wrong order. So we've got the structure on the inside, typically. We've then got our air barrier coming around the outside, so it's continuous. We then wrap it like a tea cozy with our insulation, completely continuous. So again, it's like, the body is like that. It's only where your teeth come through. And that's the bit where you have to visit the dentist every 6 months and have medical insurance and stuff, because, it's a problem. So then we've got a wind and weatherproof layer. And then external structure, whether it's porches or brise-soleils or whatever, but the important thing is no penetrations through the structure. Now, sometimes you have to do it, and but there's always a cost involved, there's a maintenance issue, there's some fancy bits of German kit to make it possible. So if you can avoid that, then that really makes your buildings cheap and simple. So here's the build-up. This is Bushbury School. We had a problem here. We actually had on the site, there were cellars and mine workings and all sorts of stuff, so it's obviously had to be a pile foundation, which is a thermal bridge problem, an air tightness problem. What do we do? So the solution there, and this was sketched on a napkin in EcoBuild, handed it to the structural engineer, and it appeared on the drawings, and it went through the whole thing, and nothing changed, so it was quite impressive. So we've got strips down the length. Do you remember on Bushbury? This is Bushbury with the one that was at a slight angle, so we had 3 strips on piles. We then put EPS insulation over the top, so that's the structural bit. We've got the slab on top. Insulation, so it's just floating, no penetrations through that. We've put edge insulation around the slab, and the load is all taken onto the structural slab and the interim walls inside. So the whole thing's completely thermally bridge-free, completely wrapped. And you see the wall build up here. This has got quite a high timber fraction. This is 140 studs taking the load, and outside it's light and fluffy. And to keep it level with the ground, because we've got level access, we've got EPS coming up until we get to the point where we're confident about using timber, so we're above the splash line and so on. So, and then thermally modelled, it's thermal bridge free by external dimensions, heat flux and so on. We get to the first floor, so then it's got to go in. We've got a compromise here. We're having to take the air barrier around. We're not penetrating the structure, that's in the same line, but we've got to wrap the air barrier around. That structural zone, we've put some insulation in the structural zone as well. We've got a service zone here to protect the air barrier here. But this is continuous, goes down to the floor and joins up with the roof as well. So this is section, so you can see the air barrier here is the OSB. We tape it onto the membrane, it wraps round the structural timber there and carries on down. Very nice, simple detail, until you get to a post in a corner on a Friday afternoon and everything goes terrible. But it got resolved. But the thing is, these things, we tend to draw something simple in 2D. It's always the corners and those sort of things we spot. So I look at this, I immediately think, oh, got a problem there, where we go change in level from internal air barrier to underneath the ceiling, but we've got to somehow go through the structure. Here we've got a 1-story joins a 2-story, and here again we've got through the clear story. So those things, when you get experience with, you think, oh, we've got some tricky details, we need to get some detailed drawings of that. So here's how they solved. So this is the air barrier. This isn't air barrier, it's just structural. The air barrier has to go through there, and that becomes the underside of the roof we saw, the lean-to roof. So it's the sort of stuff we've got to think about. Here, glulam here, because the timbers are going that way with the insulation, but we're spanning onto this, but this stops short of the outside. So it doesn't go through the air barrier at all, which makes the detailing much easier. And then the internal walls, this is an external wall, this is an internal wall. We've left a gap, so it means we can do the air tightness, we can tape that, we can run membrane through, and then we add in the timber which locks it all together structurally, and this becomes our service void. And very good detail. Took a little while for the timber frame contractor to get this. He's now on site with another school. I was there the other day. Brilliant. He's just really got it. It's not a problem. He realises why we're being tricky with him. Something else I've been doing for quite a while now. Again, overhangs and stuff, all sat on the outside of the windproof layer, so there's no penetrations there. Ventilation strategy. There's a general thing with Passive House. We're supplying to living areas and extracting from wet areas like bathrooms and kitchens. Similar idea with the school, so we're supplying to group rooms and classrooms. The air's moving through very large transfer grills, because we're also doing the natural vent strategy through the same transfer port. So that makes them quite big and expensive, but it means we're also ventilating with windows in the summer. And then we're extracting largely from the hub and the street and toilets and things which connect into the hub. And this is our air handling unit here. So that's the general principle of sending the air through there. Now, one issue is the hall. What do we do there? Because the kids, when they're in the hall, they're not in the classroom. So one method that is used is you have dampers in all the classrooms, so that if and presence detectors, so when the kids aren't in the classrooms, you shut them down, then you transfer, open up other dampers. So we could have done that. E3, as you hear from E3, came up with this very, very neat idea. We treat, if you're not in the classrooms, then the air is clean. So we're pumping air into the classrooms, it's coming out of the classrooms into the hub space. And then when the hall, we've got one CO2 monitor in here, the CO2 level goes up, the fan, we're sending air from the street into the hall and around. And we've got recirculating mixing where we can, with a heater battery, if the hall's a bit cool, we can just quickly warm it up like an air heater. So we very quickly take the chill off if there is a chill. If it's a prize-giving evening and 1,000 people, we open the windows. It's not a problem. So trying to keep it simple. So here you can see it working. So that's the horsepower. This is the recirculating with the heater. So that's just to mix the air up. But they're taking the fresh air from the street area. So other issues with non-domestic, with time control. So there's a lot of fan power. If we're running the ventilation all through the night, also you tend to make the air overly dry because you're ventilating when there's no moisture being generated. So we want to turn the ventilation off. Fine, that's easy to do with a timer. Wolfgang Feist said, the thing you must do if you do this is, it's the right thing to do, but you must dry the filters before you turn it off. Because if it's very 100% humidity, foggy outside, the air's coming through the filters, then you turn it off, the filters are all moist, and then when air's moving, it's fine. But when the air stops, then mold can grow, and when you turn it on in the morning, you can get smells and odour problems. And he says it's been a big problem in Germany. We didn't know about that, we nearly didn't do it, but we had to introduce that into the system. CO2 modulation, that's just simply built into the heat recovery ventilation units. So it'll tend to just modulate it for the whole school. We haven't got individual sensors apart from the hall, partly to keep it simple. In the summer, we're turning the ventilation off. We're still going to, in the kitchen, we're needing to get rid of heat, so we've got serious extract on the kitchen, which has its own heat recovery, which is only 50% efficient. It's just to take the chill off. That's really just for comfort. But in summer, we also got the toilets still need to have ventilation, and they're in the core, so they don't have windows. And we've got some landlocked small rooms that wouldn't get ventilated. So we've got another fan that runs in summer, but we're turning the main MVHR off in summer. It was a decision, and using window ventilation. And secure night ventilation, discussion about this earlier. Really very much built into this, that is the cooling strategy at night. We have grills that open. You see at the top here in the clear story. Behind that, there's an insulated panel. In daytime, we've got windows that open. These high ones are all on actuators. The lower level, our preference now is for manual opening. Someone becomes the night ventilation monitor, watches the weather forecast, and does this. We think this is a robust way of doing it. We've got one's automatic, one's manual. We'll see how it works. But my money's on the manual one. So secure ventilation, we leave it open for night purging. Kitchen, as I say, was a big challenge. We didn't have much information. There's a tendency that previous schools there's been overheating problems. We were pushing to not over-ventilate, not try and solve the problem of overheating with masses of ventilation, but try and reduce the gains. So we're using induction cooking rather, efficient ovens, all aerated refrigeration and so on. We've got rid of the hot water circulation, which used to be uninsulated pipe running around the kitchen, which acts like a radiator. So everything's dropping from the ceiling. So we've really gone to great lengths to try and get the gains down and then therefore reduce the ventilation rate. But it has its own MVHR with a runaround coil on the kitchen. The heating system, if you can spot it, very discreet. Radiators, just a few. I think the next school will have even less radiators and they'll be smaller, but we'll see. There's a bit of nervousness when it's your first one if people are cold in the winter, but at the moment looking good. No underfloor heating for various reasons, which we won't go into. And you see here the borrowed light that John mentioned, very effective. And the boilers, this is Lee, the job architect, 2 boilers here. And he said, bloody hell, he says, that's smaller than the boiler in my house. I got home and quickly checked the rating and stuff, and it's actually, we think we've got 4 times the capacity we need. So again, we'll see. But it's not ridiculously over the top. And that's just for space heating. We've got some Andrews water heaters for water. Domestic hot water, absolutely critical. We'll see when we get to primary energy. It's a constant battle for us to try and reduce the losses from hot water systems. Very little hot water use in the school, but an awful lot of losses from circulation and so on. Here's just a picture of services and stuff going in. Insulated pipework, vents. You wouldn't see this in a German plant room. It would all be sort of going. This, I think, it must have been his wife knitted it at home or something, but it does the job. British insulated valve cover. But you've got to insulate all the valves, all the expansion joints, all the bits. It's no good having a little bit of insulation and then bare pipe and then a little bit of insulation. We've got to get really obsessive about it. Primary energy, this is work in progress from the certification. This may change a bit. You can see ICT, computers and stuff is a bit dominant. We think that's a bit overestimated at the moment, but it's high. Kitchen, big one. Domestic hot water losses. I mean, kids aren't doing a lot of washing their hands and stuff, but it's still, the losses become quite significant. And domestic hot water use, this is using the German standard figures, probably too high, but that's what we use for certification. Heating is looking quite modest now, and auxiliary electricity. And this is primary energy. We think we're going to be under 100 when we've got everything sort of argued, and that's our aim, but 120 target. And then, very important, site support. This is George looking at that tricky corner detail again. Toolbox talks, getting the manufacturers in to demonstrate products like tapes and so on. And also just feeding that back into the design and getting everyone involved, which is something Matt will talk about. And the certification process, we're working with Warm on this, and very good feedback. It's partly, as we go, that this is information. They're saying, look, the red is we still need information. Orange, we've got some indicative information, we just need a bit more. Green is they're happy. So this is an iterative process, and the target goes up and down and as we go. I'm sure there's some quote like this, but I couldn't find it on Google, so I made this one up. And it really echoes what Jono was saying. You know, it's all the good stuff you want to put in, but the stuff that makes it brilliant is the stuff you leave out. That's the stuff that we think, it's like whether it's an iPod or iPhone or these buildings, hopefully, it's what we didn't need to do that makes it brilliant. That's me. I hope I'm run over too much. Thank you.
Good afternoon, ladies and gentlemen. Thank you very much for the opportunity to come and talk from our perspective of the construction process. It's been a real adventure for us, and when we tell our site engineers you want to build a what, that's the sort of expression we get back. But hopefully he's been convinced by now. That's Ian, who's been crucial to this project. So obviously 2 projects, 2 project managers, 1 construction manager overseeing the lot. John and Kevin, our construction manager, have been on a real adventure with Archetype over the last 5 years, building St Luke's, Blake and Hall, and now Oak Meadow School. So it's been a real learning curve for Vales working with Archetype to actually be strong-armed down the route of sustainable construction, timber frame construction, airtight construction. 5 years ago we thought it was a load of codwallop. Now we think it's the best thing we've ever done. So there's been a real learning curve for us, and we've done a lot of research ourselves. We've really wanted to understand the process. So I went over to Germany, our site managers went to Germany. We went and had a look at German construction sites and realised that actually there isn't a big deal about the way Germans build. You know, we're all humans, we have all got the same skills, and we can build exactly the same way. And that was the feedback I was getting from our site managers, was actually they're not doing anything different that we do in the UK. They're just doing it in a more controlled way. And so that gave us and our site management the confidence to actually get behind Jonathan's design and say we can do this and we can do it without adding on a load of cost. And obviously, as Nick mentioned, generally they recommend that you build a house if you're doing passive house. We thought we'd take a chance and build 2 rather large schools instead. So partnerships. I can't overemphasise that this was probably the most important element for us as a contractor, to work well with Jonathan, with Nick and with our supply chain, to go into this with a contractual, keep your cards close to your chest, let's write everything into a contract. We would not have achieved what we've achieved today. And I think that's probably the most important thing for us, is that without that sort of understanding of what we wanted to achieve across our entire team and our supply chain was really critical. Me as a sustainability manager in Thomas Vale, I can sit there and say it's a really great idea, but if our site management isn't along the same lines, then it just will not work. And so for us, this was really, really crucial. So we've gone on a learning curve to get to Passive House for us. Obviously, St Luke's was a real adventure for us, and it was a timber frame building. It was following the principles of airtight construction. We were starting to use airtight products. All of those elements were quite new in the construction industry. It's not something we normally do. We normally slap some bricks up, forget about the holes. If we cover it up with insulation, that's great. This was a real learning curve for us. And it's been a real challenge, but I think it's something that we've learned a lot from. So programme. Obviously, John touched on the programme. We didn't have a lot of time to build this. The client said, this is your programme. It's no longer. You've got to build Passive House within that time. So really it was, what can we do better? What can we do faster? What can we do quicker? But obviously, looking at Passive House construction, it's just not normal to a new build school in this country. And a critical point for us was really to try and get the shell of the building completed before we started knocking holes through things with M&E systems and so on. So the first point for us was really to build the shell. And so we had from January till June to build the shell of the building and do some minimal first fix work in the building. And that was a real change for us. Typical build programme was very much start at one end, get going and work your way down the building. Obviously we had to change all of that because that would just not work, because we had to get to our air test. And so I'll just talk about our air test programme in a moment. But in June we had an air test where we knew we had to reach that. So before that, of course, we had Nick beating us around the head to get the airtight details in and to get our supply chain. to really understand what we were doing, the concept of it all. We had this wonderful little cardboard model which we could take apart and look in and say, well, that goes there and this goes here. And all of that was really, really important to us really getting on with this. So, programme of air testing. We wanted to do a room in April just to test it, to test the concept. We got 0.69, which isn't obviously what the passive house standard is, but we realised actually that was probably missing the point a little bit, because if you air test a room, you're missing the whole concept of the building, so we probably wouldn't even bother doing that again. So we left that alone, went straight to the June air test, and got 0.34, which was a huge achievement. I think that was at that point probably the tightest school building in the country, and something we were really proud of. But unfortunately, Kev, our construction manager, was on holiday at that point, so he wasn't around to pay for the drinks to celebrate, so we had to just carry on building, which was a real shame. And then just a week and a half ago, 13th of October, we got the final tests, which is 0.48. So we achieved passive house from a construction point of view. Something we're really, really proud of. We're still building schools as a contractor that are nowhere near these levels, 5, 6, 7 air changes. So a 95% improvement on building regs. So obviously we also have a range of modelling going on to model air test equipment. What's also interesting is I believe that's actually a significant smaller door blower than you would have typically on a building of this size, because just could not measure the air pressure in the building. And obviously Nick and Alan are available for further modelling if you require. Speak to them after. The thermal imaging. I don't know how many building projects where you have guys going around with thermal imaging cameras. I think this is the first time we've ever done it. We are actually taking images during the construction process. So again, this was really critical because obviously it showed up that there were there were areas where we had air leakage, windows, clear story, ventilation ducts. All of those areas are leaking heat, and we had to do something about that. Again, if we'd done this at the end of the project, we wouldn't have been able to rectify it. It would have cost us a lot of money, a lot of time, and we would still be working on the buildings, but we've handed them over. Again, smoke testing, that was the, where was that? Remind me. Curtain walling. Curtain walling, yeah. We had some issues with... Sorry?
Or a sliding door.
Or a sliding door. It's a curtain walling or a sliding door, but it's a smoke test. Again, I think the point is, we're testing the building as we're building it. Again, something that is unheard of in construction these days. Some further testing. I started to wonder if that was a lightsaber, but apparently it's a smoke test. So we had some happy architects when we got to our 0.48, and that was a real achievement, a real collaborative teamwork. So I just want to touch on supply chain. Obviously, I've talked about collaboration and working together, but it's got to go all the way through. It cannot just be at the design stage or just with the contractors or with the sustainability people in the contractor. It's got to be right through into the supply chain. And so working with, we had to really bring on board our supply chain. We had 2 timber frame contractors, one on each project, which was quite an interesting exercise in comparing how each one performed. But again, they worked really, really hard. And you can't underestimate the effort that went in terms of the real work that went into detailed design of each of those elements of the timber frame. Really critical. Windows, again, we had one window manufacturer on board, and they were able to get German window parts into the UK and assembled in the UK so that we could get them onto site in time. Previous project, St Luke's, we had Swedish windows, and they were actually delivered 16 weeks late, which was a major problem for the company, for us. Our guys worked around it, and we managed just about to hand the project on time. If we'd had 16-week delay on the project, that would have pushed our whole air tightness checking programme out until we would still be doing our first air checks now. So that's a real issue, is actually delivery and supply of products. If we're relying on European manufacturers to supply our products, then we're going to have an issue in terms of supply control. If we can get them manufactured in the UK, we've got much better control, which was something that we had to learn early on and encourage our supply chain to take on board. Air tightness tapes, obviously it's a whole new concept again for the guys installing these on site. What's an air tightness tape? What goes where? How do you install it? What's it do? Why am I doing this? All these sorts of questions where you have to overcome. So again, we had a lot of workshops, a lot of time with Nick and Alan, just sitting down, explaining things, understanding what the project is, what the concept is, how it all goes together. And then managing the cost, because as soon as you start saying you want to do something innovative, people add on 10, 15, 20% onto the project, just because they don't understand it or they've never done it before. So again, that was our QSs really getting strict with our supply chain and really understanding the cost of the project. So some challenges for us. Obviously, it's not all plain sailing. Building the largest thermal bridge-free slab in the country was quite a challenge. And again, one we've achieved. But hitting that straight edge, again, real tight tolerances, with plus or minus 5 millimetres on the edge of that slab. If we didn't get that tolerance, then the insulation wouldn't wrap round up into the timber frame and round into the ground. So we had to really be careful and really concentrate on that slab. And that was further challenged by the fact we were casting that slab in the coldest winter we've had in something like 20 years. So again, that caused us some problems. But getting around it, and big lessons learned, we used timber shuttering the first time. Next time we'll probably use some sort of metal shuttering or even an insulated formwork around the slab. Lessons that we really needed to learn. Windows, probably the biggest cost in the building, but also probably the biggest challenge in terms of installation and getting it installed right. Each one of those tapes had to be installed and checked and put in properly. And you can see that there's 3 different tape products around each of those corners. Again, that is something completely different to the way that we build normally. And getting that understanding into a supply chain, into the fitters, is a real challenge. And each of those tapes then had to be checked to see if they were sealed in properly. So costs. Everyone always asks about the costs. A few years ago, Capita Simmons did a sort of cost model of a sustainable school, which was a BREEAM excellent school, which they came out with. A square metre cost us £2,151 per square metre, with an M&E element of that of £454 per square metre. St Luke's we delivered for just over £2,000 per square metre, and we brought that down again for Oak Meadow and Bushbury, which are passive house. So really the point I'm trying to make here is that we're delivering schools on cost. The cost that we require, just over £2,000 per square metre, with that M&E element forming part of that. So yeah, M&E is slightly higher on the passive house schools. Again, potentially that would come down if we reconciled the heating strategy in the building and looked at the ventilation strategies and see what we could do again. And we really believe that obviously we don't want to leave the project there in any sort of way, and we really believe we can actually take that down even further. We've had a number of workshops post-construction on how we can actually redesign the building to improve that number. I'll just note that those numbers are exclusive to groundworks and landscaping. So really, just in a quick conclusion from my point of view before I hand back to Jonathan. For us, passive house is the future of construction. It's critical if we're going to achieve the carbon targets that the government is setting, that we're not going to, with energy prices skyrocketing. But probably the most important thing, 2 important things really that I want to point out. First of all, we can build this in the UK. It's not a magical German standard that no one else in the UK can do. We can do it, and we've done it. And the second point really is if we can take a partnered and collaborative approach, then it's achievable. If we get contractual, it will never work. So thank you very much.
So just to conclude very briefly, Archetype and Thomas Vale's now developed a joint venture to respond to the challenge of the James review in bringing down costs and achieve standardised construction. So we're now targeting in future projects achieving this with 20% less by further working our integrated design team and our supply chain and using a fully integrated BIM approach to how we work. And you can find out more about it on the stand downstairs. But in conclusion, how have we achieved it overall? Well, I think critical thing is we had an integrated total design team commitment from every member of the design team from day one. We worked very hard and appreciated and used and listened to the passive house expertise of Nick and Alan. Critically, we integrated passive house into the design from day one. I think if you add passive house at some point during the design process, it will always cost more. If you integrate it in, you can make it work. We had a constant focus on value engineering at every stage in order to achieve the costs we just had to achieve. We had a committed contractor in Thomas Vale dedicated to delivering it. Throughout the whole construction stage, that ongoing teamwork continued at every stage with focus workshops with all the key subcontractors and commitment from them, and then an ongoing process of rigorous and regular site inspection. And on delivering 2 major schools to this standard, we've got not one single piece of contractual paperwork on file in either direction, which I think demonstrates that type of collaboration. This was tweeted by Wolfgang some time ago. I think just to summarise the idea of simplicity, where we were in the 19th, where we got to in the 20th, and where we are heading, hopefully, with Passive House in the 21st century. So finally, we believe in Passive House, not because it restricts design, but because it is logical, evidence-based. It does encourage simplicity, but most of all, I believe that it frees us up to be creative. It doesn't restrict our creativity, it enhances it, because we know that the building's going to work. At the end of the day, it does deliver, we all know, reduced costs. We can, I hope I've shown, and we've shown together, also achieve high quality design, beautiful architecture that uplifts the spirit at an affordable cost. Many thanks.
Thank you very much to our excellent speakers there. So, project on time, on cost, even the presentations are on time. If you'd like to take your seats at the front. Some very strong messages there in terms of, I felt, the psychology as well of the approach, as well as the contractual. It always reminds me of the story of Reedburg School, you may be familiar with it, how they first commissioned the M&E team, where traditionally M&E teams were paid based on a percentage of the amount of kit that went into a building. So, of course, more kit, more fee. In that situation, they changed it and said, how much would you normally make on your fee on the kit? They said, this much. They said, now design all the kit out. You still get your fee. Do what you're trained to do. Here's your creativity back in the hands of the people who can do it. And it seems that that philosophy worked very well on this project. So we've got 10 minutes for questions. We can overrun by potential another 15. But I'd like to hand it out to the floor for questions. Yes, Nick.
I can do that. When we did the pre-test, there was a whole building, but the window actuators hadn't been fitted. So John, who you saw the picture of, he had gone round and put seriously big screws and bits of 4x2 holding the windows shut. So the final test was done with the actual window actuators. So that's something, it's not that there's anything wrong with the window actuators, but we've learned a lesson about how the vent panels, particularly the night vent panels, will flex, because they're a bit more flexible having insulated panels rather than glass in them, for instance. So it's still fine, but we know the actual building, we saw no evidence. I mean, there will be leaks, but there was nothing serious. We're pretty confident that that's where a lot of the leakage. And also the doors, we had to compromise on the door. We used a Rayco door, non-passive house, thermally broken aluminium. We need something tough enough that didn't cost €5,000 per door, that wasn't too heavy and so on. So the door was, with the timescales, was a compromise. Next time we think we can find a better door product. But it's that sort of stuff. It was doors and windows, I think. Okay, so it's not. There's a few extra holes from M&E, but that wasn't the big. We blocked some of those up, and it made no difference. So
what sounds really interesting is you managed to get the education to you guys on site. Then you've got your fabric, you've got the air barrier working, and then people don't come and put holes in it afterwards.
Yeah, that definitely happened. And I think the lesson for us next time is to have less actuated openings and more. You can't really beat something with a handle that you can open and shut and lock an actuator, and you can never quite push the to fully closed. And I think the other challenge, which Nick mentioned there, was doors. I mean, we have a slightly different threshold height allowances for disabled access in the UK. There's a real desire amongst teachers to have big sliding doors, which are very difficult to achieve air tightness with. So, and obviously in a school building, they need all to be very, very robust. So all of those things just made, in final resolution, air tightness not quite as good as at the intermediate test, but still above, or rather below the level we needed to achieve.
Yeah. James Pickard, Pickard Architects. How have you addressed overheating in the summer? Because there have been a few schools in North of England built under BSF that overheated 2 or 3 years ago quite badly.
Let Hugh answer that.
Maybe Hugh could join in in a minute on that, but just to start that off, I mean, we had sort of confidence of monitoring St Luke's School over 2 years, which is built to a very, very similar standard, lightweight, heavily insulated timber construction. At the time when we were in the design phase of that, we looked at getting the right amount of thermal mass within there using dense thermocell board to a certain thickness for enough for night cooling. And then a ventilation strategy and a shading strategy. And we've monitored that through 2 summers and some very hot periods. And all the evidence in actual measured data and user feedback is that it stayed beautifully cool. So that the strategy of night cooling in a lightweight school building seems to work. But we've got our M&E engineer, Hugh. Do you want to add anything to that, Hugh?
Not really, I don't say, just to do what we normally do on buildings, which is we use IES as opposed to TAS, but it's a dynamic thermal simulation looking at heat gains from obviously the sun, internal heat gains, and balancing that against ventilation openings and thermal mass internally. So no different to any normal building. Obviously the challenge being that you've got more south-facing glazing generally on a passive house building, so we just have to take extra special care.
There's just one thing that was interesting in the design process. The serious checking was done with IES, a dynamic model. We also did our own little check with PHPP, which is not really designed for big commercial buildings, but as long as you haven't got a tiny room with a huge amount of glass, if it's fairly evenly distributed, it should give a fairly good result. And we were sort of cross-checking, and we were messing around with that and trying different shading and so on. But I think our main thing that Al and I are most confident with is trying to really reduce the gains rather than come out with very clever cooling strategies, apart from the basic night cooling. And we're more interested in getting the gains out, so whether it's insulating the hot water, reducing the circulation, getting the glazing down as little as we can that gives good daylighting, using fixed shading and so on where we possibly can, not relying on movable shading. We haven't done any movable shading. In another job you might have to, but it's just always something that can go wrong. So just driving the gains out. It's like with the heating, we want to get rid of the losses, and for the cooling, we want to get rid of the gains, and then everything else is just to mop up what we failed.
Cindy.
Underfloor heating, we think of that normally as a very energy efficient means of heat delivery. Over to you, Nick.
Yeah, okay, there we go. I mean, in theory, you could, if we were going to use a heat pump, say, then we'd probably look at underfloor heating, but we'd be running the floor but we'd running at 1 degree. We wouldn't be looking at room temperature. We'd be looking at floor temperature. We'd run it. We'd work out the emission from the floor, and it'd be about 21 degrees or whatever, about a degree above room temperature. So we'd actually control that. We've not done it, but that's the theory. If your thermostat says, oh, it's cold, and the heating comes on and goes up to usual floor temperature, then the thermostat says it's fine, and it may have only gone cold because someone opened the door, then you've got more kilowatt hours in that floor than you need for 3 days of heating in that room, and then the kids come in and they're producing enough heat anyway. So there's just, it's
the controllability.
yeah, it's just, and the mass is just not really. But if the clever way to do it in the passive house will be to run it at. So then, when the room's warmer, it's the floor's gaining heat.
But
Self-regulating.
the big issue I think is controllability, because obviously when you've got a heavily insulated passive house school building, what you don't want is a long thermal lag. So that if you've got underfloor heating, that will heat up and emit heat. The thermostat goes off, it carries on emitting heat for 2 or 3 hours, even though you've got 30 kids just arrived in the building emitting heat. So what people then have to do, open the window to cool it down again, then the thermostat comes back on again, the floor comes back on again, you can't control it. So really the only heat we need in the school is a quick response heat early in the morning, just before the kids arrive, just to bring it up to temperature, to top it up if they leave all the windows open at lunchtime. It's just a quick response, top up, that's all it's doing. Most of the heat, most of the time, most of the year, is coming from internal gains and solar gains, people, equipment. And what we need is a quick response. If we had a slow response heating system, it would just overheat. And that's the other reason for not having too much thermal mass in the building. When we did our calculations, if we had too much mass, too much heat will get stored and we can't get rid of it. So it's actually having enough mass for cooling and not too much for overheating.
And also from a construction point of view, it's easier to install a wet radiator system than it is to install underfloor heating. It's cheaper, and 2-storey underfloor heating isn't fun. So
and also in terms of controllability and the whole thing about keeping buildings simple, you actually can't get much simpler for a heating system than a gas boiler with a time clock and thermostatic radiator valves. People understand that. You can't go wrong really, and you can control it very easily.
Just quick, one last thing on that. There's underfloor heating for years when we were trying to, as you say, it was seen as energy efficient. We were trying to get people convinced about it, and they didn't want it. They wanted radiators. Now we've got the opposite problem. They say, oh, we want underfloor heating, it's nice and comfortable. When we walked into the school the other day when we were doing the air test, it was just, someone left the heating. It was just nice temperature. Everyone, you were feeling the floor, feeling the radiators, very even, very nice, like you would get with underfloor heating in a not very well insulated building. Sorry, Sean.
I just wondered what led you away from delivering the top-up through the ventilation system. I mean, was it
Oh God, it's just me again. Okay. I mean, even in there's a big debate about that with housing and so on. I won't go there. But with the school, I mean, you're providing the heat when you're not ventilating. So before the kids come in, the heat temperature shouldn't drop. It's just if it's dropped below 18 or something, the heat might come on. It could be in the middle of the night. So the heat will happen when you don't want the ventilation. When the kids arrive, you don't want heat anymore, but you need to ventilate. So it's a bit out of step. And also, but we are using air for the hall, where we've got this big volume that, if we want to suddenly get it warm and just knock the chill off the air, I mean, all the surfaces are fine. We've got the potential. We may not need to do that. It may never be used, but we've got the option that we can very quickly get the hall up to temperature in minutes.
Can I just add something to that? There's another half to the answer to that question, which is controllability on a room-by-room basis. Because if you temper the air after the air handling units, you raise the temperature, it might be that that's actually too warm for some of the spaces, but not warm enough for other spaces. So if you have the control in the room, i.e. using a thermostatic radiator, that simplifies things.
I'm just saying at this point, we're a few minutes past 5, but we could go, the drinks are at 1:15. If people are happy to keep going for a few more questions, but we don't want to be late for the final address at 1:30. Is that okay with everyone? So, the question from Andy.
There's an implication about thermal mass there for schools, where you have this big transient heat there with kids coming in and so on. Would you go as far as saying that using dense masonry in a building like this would cause problems, or would you
Well,
go that far?
My gut feeling is that it might do, but I think the proof of the pudding will be in the fact that we've just finished 2 passive house schools using heavily insulated lightweight timber frame. And down in Exeter, NPS have done Montgomery School, which takes a concrete heavyweight route. So we'll be able to see and monitor both versions in practice and actually discover how they perform differently. I think it's too early to say. My gut feeling is that too much mass in a school might actually work against performance, but I think I'm open-minded until we see the results of both passive house schools in Wolverhampton and Exeter being monitored over a period of time.
It's just interesting because the passive house offices in Essex, we went big time for maximising solar gain combined with a lot of dense block work. And I'm aware, they do have to pay attention in heat waves to nighttime cooling, otherwise you can rush it up in terms of temperature. So it's
Well, that's obviously what we're trying to avoid, is having just enough mass to allow us good night cooling without too much heat building up, because when you get a classroom with 30 kids in it, there's a lot of heat coming from those kids, and too much heating in the mass could easily work against us and cause overheating.
I mean, a lot of the glass we've got on these buildings isn't required for passive house. We were actually trying to say, look, we want less glass. It was, it was either a view or creating connection with outside, the curtain walling coming to the ground and so on. So there's stuff we quite happily get rid of all the glazing below 800 millimetres in terms of passive house and energy and daylight. So, it's not, some of the, where we've pushed it a bit, it wasn't a passive house requirement for extra glazing.
I've got one question myself. Obviously a very collaborative working process. At which points did you keep updating the client on obviously a lot of different systems, a lot of different approaches to what they've been used to? How did you keep them informed, or were they key to the process all the way through?
Yeah, I mean, we've had a very close working relationship with the client, Wolverhampton City Council, but also the users of the schools, the head teacher and the governors, the teachers and the children. We've actually been doing a sort of pilot soft landings process in a number of our projects. And so Lisa, who was doing our research and soft landings pilots, was actually coming to attend design team meetings and when she was monitoring St Luke's School and actually creating a sort of iterative feedback loop. So the client has been very on board. For them it wasn't that radical because they'd already worked on a number of projects with Archetype, St Luke's School and 2 or 3 other projects to almost passive house but not quite. So for them it was quite a small step forward, but it was important they were taken on the whole journey with us. But just to give you an illustration about how collaborative that process was, the children have been involved in a whole ongoing series of arts projects. If any of you come to visit their schools, you'll see that they're now full of pieces of children's artwork that are integrated into the architecture. For example, the risers on the stairs have a picture going up the children have done, and all the manifestation of the glass is done by the children. But we had a group of children, 10-year-old children from one of the schools, up to our office for a sort of half-day workshop. They got out of the coach and they walked in and started wandering around. They were saying to us, come and show us where your thermal bridges are on this building. These two projects are the result of several years' collaboration between Thomas Vales, an archetype, our design team, Nick and Alan, and the client. And you see the benefit of that, absolutely, because you're not making the same mistakes, you're not having to explain everything from day one, you're actually learning from one project to the next. And that's what we're now, Vales and Archetype, wanting to do with our sort of joint passive house standardised approach with the same design team, with the same supply chain, to actually show that when Michael Gove and James Review say they want to deliver standard schools at unbelievably low costs, that we can compete, maybe not to the absurdly low cost they're talking about, but sufficiently near to those costs to actually say to people, you can get down to that level and you can also have quality architecture and you can have passive house rather than rubbish that's going to fall apart and cost a fortune to run in the long run. So that's what we're aiming to do.
So essentially we can have our cake and eat it there. And I think we'll have to leave it possibly at that point. Is it a quick question?
Just a quick thing.
There we are. We'll take one more
I
and
know
then we'll
push
break for
feet.
drinks.
You need 4 people to walk together in Bush Feet. It's a pretty rough area. Any problems with secure by design?
No, we obviously consult with Secure by Design. I mean, we've done, every project we've done in Wolverhampton has been in what we've been told is the toughest bit of Wolverhampton. And what we have, our belief, I showed you the pictures of St Luke's, which is a lightweight, friendly, open, outward-looking timber-clad building that most people approach with a tough inner-city area would have built a fortress with shutters and brick. And that just says negative things to and about the local community. And in that case, and in another case in Bilston, where we've already built a school to a similar approach, they've had no vandalism whatsoever in the several years since they've been open. I think because people actually feel that it's a school that belongs to them, that says positive things about the community rather than negative things. And so, that's the approach that we believe in, to actually work with the community and be positive and warm, create uplifting buildings rather than negative security fence buildings.
Thank you. And I'm afraid we'll have to leave it there.